Okay, so we were talking last time about trig equations and uh, starting to solve those trig equations. And one of the things we recognized very quickly was that there really is an infinite amount of solutions, right? Because this graph continues through many, many cycles. So often what we do, instead of looking for all of them, because we start writing them down now and continue writing them down a very long time from now, is we very often look for solutions just between 0 and 2 pi, or we're asked to list a certain number of solutions, or sometimes we're asked for the general formula. So if we're going to kind of start from the easiest and move our way upwards. So if we're looking between 0 and 2 pi for solutions, then we begin, as we're doing here, we're then only looking in this area here. Then we begin first by finding the reference angle. Find the reference angle. So what angle gives us a cosine of 1/2? And we recognize, hey, that's pi over 3. That's the inverse cosine of the absolute value of whatever that thing is. The absolute value of whatever that thing is. Okay? So we're using that. And so we make use of that idea. Okay? And so then once we figured out the reference angle, we then take that reference angle and we put it into the quadrants that matter for that cosine. In this case, it's a positive 1/2. So we go to the quadrants where cosine is positive. That would be the first quadrant. And in the case of the cosine, that would be the fourth quadrant. And we take that pi over 3 angle and put it into both of those quadrants as the reference angle. And then we work out what those angles are. And those would be our two solutions between 0 and 2 pi. So here, the one answer is in the first quadrant, so that would be pi over 3. The other answer is in the fourth quadrant. Remember, that would be short of 2 pi. So 2 pi, take away pi over 3, or 2 minus 1/3, would be 5 pi over 3. 5 pi over 3. So that's the first setup. That's the first beginning process. All the angles within 0 to 2 pi. All the angles within 0 to 2 pi. Okay. The second thing we're asked is to find all the solutions, or list out a certain amount of solutions. So in this example, we might be asked to list 6 solutions. So we already have 2, right? Pi over 3 and the 5 pi over 3. So what we do now to list out additional answers is we find angles that are coterminal to the ones we just found. Angles that are coterminal to pi over 3 and 5 pi over 3. Now remember, to find coterminal angles, we just start with our angles and start adding on multiples of 2 pi. So we can begin with pi over 3 plus 2 pi. Well, that would be 2 and 1/3, or 7/3, or 7 pi over 3. Or we can take our 5 pi over 3 plus 2 pi. That'll be 2 and 5/3, which when we convert it over to a fraction would be 11/3, or 11 pi over 3. Now we could add on another 2 pi. onto each of those, or we could take off a 2 pi. So in the case here, if we took off 2 pi, pi minus 2 pi, that would be 1/3 minus 2, would be a negative 5/3. So negative 5 pi over 3. And likewise, if we took the 5 pi over 3 minus 2 pi, we get negative pi over 3. So now we've come up with 6 different answers. And so now we're ready to turn to the third possibility. Which was to list out the general solution. The general solution, for the most part, just takes the idea that we just had, which was adding on or subtracting off multiples of 2 pi. So it's actually a little bit, once you understand what's going on here, writing out the general solution is actually a little quicker than what we just did. And so we just take our two solutions there, pi over 3 and our 5 pi over 3, and say, hey, it's that answer plus any multiple of 2 pi. Okay. And the other one will be 5 pi over 3 plus any multiple of 2 pi. Now, sometimes in some weird circumstances, you can actually reduce these two answers down to a single answer. That usually happens with tangent functions. But aside from that, we generally end up writing out the two solutions.